Hello and welcome to third lecture in our comprehensive course on machine learning, data science and artificial intelligence. We are doing numpy advanced in this chapter and last we had done this thing, how to do stacking of numpy arrays. We ultimately concluded that there are so many different ways of achieving stacking, but it is beneficial to just remember these four commands: hstack, vstack, dstack and column underscore stack. The advantage is that both all four take same arguments, a tuple separating which has a comma separated list of the arrays which you want to stack. And it is not even limited to two arrays, but you can even stack three arrays or four arrays: A, comma B, comma C, comma D, or and so on. Okay, and all stacking we will do mostly in our course using only these commands. So other commands you can consider just for the knowledge. Now reverse of stacking, that is splitting. For example, you have created this kind of arrays by stacking. Now someone says that get the original arrays back. So you will have to slice exactly somewhere at this level, like as if this is a loaf of bread and from which you are creating two slices of bread. So take a knife and slice from this level, okay, so that there is one blue slice and there is one red slice like these two. So that process is called splitting. Again, in splitting, our work will be done by array split, split, B split, H split, and of course D split also. Okay, so let us see one by one. Splitting an array vertically. Now this terminology you have to remember a little bit, because whenever these things are asked in interviews or maybe in some tests where you are appearing, then this creates a slightly false impression in the mind. Many persons, and it is not their fault, I would say, it should be very clearly specified. But anyway, many persons splitting array vertically, that means if this green is the array, then they think that 1001 should be one part and 1010 that should be another part, because vertically they think that means like this. No, vertically means the splitter surface is horizontal, and similarly splitting the array horizontally, then in that case the splitter surface is vertical. Okay, so please remember that, because that is something very important. So splitting array vertically, splitter surface is horizontal, means actually speaking you are doing row wise splitting. So that means columns would remain same. So original array had here 2 columns and 4 rows. Then after splitting also columns will remain same. Okay, because splitter surface is horizontal. So it is as if here someone takes a horizontal intersection and pushes it inside the screen. Okay, below this line 0 0, someone takes a knife or a pointed blade like thing and pushes it inside the screen, so that 1 1 and 0 0 remains and in one array, and 0 1 and 1 0 remain in other array like this. Okay, so this is called vertical split. Okay, so splitter surface horizontal is called vertical split, and similarly splitter surface vertical is called horizontal split. So that means, again, some people get that wrong idea that if this is the array and they are asked that do a horizontal split into 2 equal parts, then they think that this should be one array 0 1 2 3 and 4 5 6 7, and this should be another array. And ideally they should remember that splitting an array horizontally means the splitter surface should be vertical, so that the 2 arrays are separated horizontally, while here the 2 arrays are separated vertically. That is why that confusing terminology, that yellow and blue are separated from each other vertically, and here the red and blue are separated from each other horizontally. Okay, so they were pasted together, and now there is a horizontal distance between them. Here also they were pasted together, but there is a vertical distance between them. So that is how that terminology comes into existence. So always remember, splitting vertically means the splitter surface should be horizontal, and splitting horizontally means the splitter surface should be vertical. Okay, fine. That is fine, but the question is how to achieve that splitting. Okay, so let us first create our 1D array, simple one-dimensional array. So I just create a list inside and pass it as an argument to numpy.array, and then I am asked, first let me print that array, and then thereafter we will see that what kind of split is obtained. Okay, so first array, and a very simple example. So exactly this kind of array is obtained. Now splitting into 3 equal parts. So at that time you have to write nc.split. Now neither you are using H split, neither you are using V split, nor you are using D split, but you are just using ordinary split. And what you want to split, that is first argument, and in how many equal parts you want to split, that is the second argument. And you can see that it is 10, 20, 30, 40 and 50, 60. Now obviously that means the number of arguments in this case should be even, otherwise it will not be able to split into 3 equal parts. Okay, let us try what happens if I keep the odd number of arguments. Okay, so and still I try to do the same thing. So now my array has 7 arguments, and if I split it, it immediately shows the error that array split does not result in equal division. So one important limitation of this np.split is that it can work only if equal length these parts are possible to make. Okay, so that is the reason why we have to. It cannot make unequal parts. That is its important limitation. Now this is what I have explained. Okay. Now the question is how to do unequal parts. Then for unequal parts there is another command, that is that previous one was np.split. This is np.array split. Okay. So if you write same array or maybe another array because I want odd number of elements, so then np.arrange 11. What this will create, that we know that it will create all the array, all the elements from 0 to 11 but not including 11. So it should create something like this. Okay. First I will print it so that we are assured that it is creating something like this, and then I use np.array split. But first this. So how many elements are there? Now here there are 5 elements, then these are another 5 elements, and this is 1. So that means total 11 elements are there. If I try to use np.split, it will not work, that we have seen, it throws error. But if I write np.array split, it can work. It tries to create as many equal elements as possible, but when it runs out of members, then in the last array it keeps only whatever are left. So it divides into 4, then another 4, and in the last it has only 3, so it keeps them. So np.array split is my favorite because it can work with odd or even both numbers of arguments. Suppose here I can instead of np.arrange 11, I write np.arrange 12. Now what is the output? Then how many elements are there? Then 4, then these 4, and these 4. 12 are there. If I write array split, then it is dividing into equal parts. So that means instead of using a limited command which works only for when equal divisions are possible and throws error when equal divisions are not possible, you will obviously use this command, because most of the time you will not be knowing in advance how many members are there in your array. Okay, here you are creating arrays, so it is a different thing, but most of the time you will not be knowing how many members are there in the array which you are trying to split. So at that time it is better to use, not better, but it is always use np.array split for splitting array. Okay, fine. Now this is the example of D split. Now D split is usually, as I say, D stack for stacking the two arrays, this left side diagram, bigger one, and D split for again splitting that array to back to the original array. This is not much used, and the reason is only one. There is nothing difficult about it, but the reason is only one, that mostly data is in spreadsheet format. So that is a spreadsheet, say an Excel spreadsheet or a CSV file that will have rows and columns. So these are columns and these are rows. So that is why the spreadsheet does not have depth. Okay, and therefore you don't need to do that for most of the data. Okay, but sometimes there are certain functions for creating 3-dimensional diagrams using Python, and there you have to pass the argument also in such a manner that it has 3 dimensions. Now there the problem is that most of the time originally you will have only a 2D like this kind of thing, and then you have to first stack it so that a 3rd dimension on axis 2 depth dimension is added, and then you will pass such data into that 3D plotting function. Okay, so that is one thing. So here we first create this is our previous lecture discussion only, that we create a np.0 array 3x3 array blue colored, and np.1 array 3x3 array red color. Okay, and using dstack we create that array. We can even print dstack AB, and you know that the printing output is not very user friendly. You have to use your some imagination that you are looking from this side. So all these 000s, they are coming in the front, and if you are looking from this side, then this becomes the back side. So all these ones, 111, and 3 times this 111, and this here also, they are on the back side. Okay, but better is that you can just remember dstack AB dot shape rather than. So you can immediately see that it is 3 rows, 3 columns, 3 rows, 3 columns, but depth dimension or the 3rd dimension along axis 2, that is also now 2. So fine, it has been stacked. Now I want to do reverse. I want to get the original blue and red arrays back from it. So obviously I have to split. Then that is actually the original stacked array to 332 array, and just I have to write np.dsplit in how many parts you want to split. Okay, so split arrays is equal to np.dsplit, but that split arrays will have as many elements as this number which you are specifying. So if you are specifying 3, then it will have 3 elements. If you are specifying this, then 5, then it will have 5 elements. So then to get each individual, you will have to use subscript for these split arrays. This split array is also a numpy array. Original array that is this array. Now I am doing this operation, splitting operation. So this is my original array now when I want to get something. So if original is numpy array, then after using this split also you get a numpy array. But that numpy array, its first element you have to access by index 0 and its second element you have to access by index 1. That would give me my original 2 array. Okay. So let us try, and here also I can add one. Okay, first let me do this, and let us try to print original underscore a comma original underscore b. Okay, and you can see that this is my original underscore a up to this, and this is my original underscore b. So one was array of only zeros and another is array of only ones. However, those who have seen carefully, they are realizing that actually, are we getting the original arrays actually? Then no, because this 3 square means you are still getting a 3-dimensional array, while original arrays were 2-dimensional arrays. So what I am saying is that I can add one line here below, that print a dot shape comma b dot shape and control enter. You can see that they are 3. While here if I print same thing, a dot original array dot shape and original underscore b dot shape and press control enter, you can see they are 3, 3, 1. And that was expected because while stacking, a new dimension was added along this axis. So when you split, then this is now actually 3 by 3 by 1 array, and this is also 3 by 3 by depth wise 1 array. Now someone may say, I insist that I want exactly original, which was a pure 2D array. This is not a 2D array, still it is a 3D array. Then the extra dimension which was added while stacking should be removed while splitting. But unfortunately, there is no split command which automatically removes that extra dimension. When tsplit does the split, it can create the 2 arrays, that is fine, but it cannot reduce that extra dimension. So to reduce that extra dimension, you have to add one more line, that is this, that original array, original a is equal to the original a which was obtained by tsplit dot squeeze. Squeeze is reverse of stacking. Stacking increases dimension along the axis 2. Okay, makes the array sort of thicker. Splitting should decrease the dimension along axis 2. But it could not decrease the dimension, it could split, but the dimension third remains 1. So if you want to squeeze along axis 2, then you have to use the command squeeze. Okay, so then if you will see here original array and even print original a dot shape comma original underscore b dot shape. Okay, and this. Now if you will see here last line shape, then you will understand that now you are getting your pure 2D array. So for stacking, there is no need to add dimension, but for splitting, we need to squeeze the added dimension, okay, so that we get the original 2D array. So that is one small thing. In next lecture, we will be doing this part, vectorized operation and array broadcast. Now, actually speaking, this we have already done in previous lecture, but this is so important strength of numpy that even at the cost of repetition, I will do it. Okay. So next lecture. See you. Thanks.